Okay, so today we are going to start reviewing for your semester exam. So your test yesterday, I graded almost all of them. I have just a couple left that I'll finish grading today and type in. If you failed your semester, or if you failed your test, okay, your semester exam review is a test grade on this quarter. We're going to do most of it together, so that should be an easy way to bring up your grade. However, instead of giving you one giant packet and expecting everybody not to lose it, you're going to get 4 packets, so that makes each one of them worth 25 points. So your test grade right here is going to be out of 25. Okay, and you'll get 4 packets. Each one will be 25 out of 25, and they'll add up to 100. So if you didn't do well on your test yesterday, okay, then this could really help offset that, because this counts as a test grade too, and we're doing almost all of it together. Also, it'll help you study for your review or your exam, so it should be like a double bonus. Okay, so the only parent functions that are on your exam are the 4 that are on here. So you only have to know these 4 shapes, and you really don't have to memorize them because you have a graphing calculator. So if I graphed y equals x, what would the graph look like? It's a what? It's a line. It goes through what point? 0, 0, which is the origin. Okay, so there's your graph. If I were to do the domain, does my graph ever stop going backwards or ever stop going forwards? So I would say x is within where? Yep, and do you remember that little abbreviation? Okay, x within all real numbers. Okay, same thing for this one. Now my range, do I have a lowest point or a highest point? No, so that would be y within all real numbers and all real numbers. Now on my line, do I have a max or a min? No. Goes up on one side, down on the other side, so I'm going to put none. And then for a symmetry, okay, remember that we talk about reflectional symmetries, but you also have a rotational symmetry. If I spin this around, would it look the same? So this has a rotational symmetry of 180 degrees. So if I were to spin the graph around, it would look exactly the same. That's another kind of symmetry besides the reflection that you're used to. Okay, look at the next one, x squared. What shape is that? X squared is a what shape? U. It also goes through the origin. And remember that the parent graph opens up. Now for my domain, on this side I'm going back to infinity forever. On this side I'm going forward to infinity forever. So I would say x within r. But then for my range, I do have a lowest point. How low does my u go on the graph? To 0. So interval notation, you would do this. Set notation, you would do this. Oops, that should be a y. Okay, and then do I have a max or a min on that one? Okay, that's a minimum. Very good, because this is the lowest point, and it would be 0, 0. Now, do I also have a symmetry? Do I have a line that cuts it perfectly in half? What about this one in the middle, right? I do the y-axis. Does that cut your u in half? Okay, so you would say the y-axis is a symmetry line. Okay? 2 more left. Next one is the square root graph. You can remember that the square root graph looks kind of like the square root sign. It starts at the origin, and then it curves off to the side. Now, you don't have an all real numbers on the domain or the range for a square root. So for my domain, how far back does my graph go? How far to the left? 0, and then it goes all the way till infinity. Grab your packet, Legend. That's okay. We're reviewing for the semester exam. Okay, and then for my range, I would do 0 to infinity as well. Remember that you always want to go from the lowest point to the highest point. That's why 0 has to come first, infinity has to come second. Now your domain for this one is going to be x greater than or equal to 0. Range will be y greater than or equal to 0. Oops, and then I forgot to put, do you remember this thing where they do squiggle, x bar? That's what it'll look like on the final. But remember that it's multiple choice, so don't let that throw you off. But if you forget to put it on your packet, then I don't care, that's fine. But that little bracket thingy in the X bar should be there as well. Okay, does this one have a minimum? Yes, how low does it start? 0, 0. And then it does not have a symmetry. It doesn't have a reflectional symmetry, and it also doesn't have a rotational symmetry. So it doesn't have one at all. Okay, last one that's on your exam is absolute value x. What shape is absolute value? A V. Very good. So still goes through 0, 0. Still opens up. The only difference is it comes to a point instead of being rounded like the parabola. My domain, this side goes backwards forever, this side goes forwards forever, so it'd be x within all real numbers. Remember, your set notation would be squiggle x bar, x within all real numbers. But my range is lowest to highest, and I do have a lowest. How low does it go? It'd be 0 to infinity. Very good. Then my range, I do squiggle y bar, and then y greater than or equal to 0. Okay? Do I have a minimum or a maximum on this one? Yeah, I have a minimum. How low? 0, 0. Does this one have a symmetry? What's the symmetry line going to be? The y-axis. Very good. Now remember, specifically this is a reflectional symmetry. Okay, the only other kind of symmetry is a rotational symmetry. So if you want to make a little note of that, you can. Now the other, we talked about a bunch of different graphs. None of them are really on the final, except for that you should just know that x cubed and cube root x are these two. X cubed is the squiggle up and down, and then cube root x is the squiggle that way. And so you should just kind of basically know what they look like, but they're not covered really on the exam. Okay, so this one's an up and down squiggle, still goes through the origin, and then this one is a side to side squiggle, still goes through the origin. So you should kind of know what they look like, but other than that, they're not really on your final. Okay, go ahead and turn the page, please. Okay, remember that all of these different numbers in the equation do different jobs. So the number on the in the very front tells you if it's a stretch or a compression. Do we remember what the cutoff is to know if it's a stretch or compression? It's 1. If it's bigger than 1, it's a stretch. If it's smaller than 1, it's a compression. Okay, so 1 is the cutoff. Now, if it is a 1, then you don't have a stretch or a compression. It's just staying the same. Okay, the number in the middle tells you if it's going left or right. And the number at the back tells you if it's going to go up or down. And I'm going to put translate up or down, because remember, this is like moving it side to side, not opening up or down. Now, what would tell you if it's reflected down? A negative in the front. So this in the front, the plus or minus here, tells you if it's reflected or not. And remember, it'll be reflected if it's a negative. If it does not have a negative, it would just be normal. Okay? Correct. Okay, so look at number 2. What is the negative? We're just going to go through each of the changes. Each one has 3. Okay, so here, here, here. These are my 3 numbers. What does the negative do? It reflects it down. What does the minus 3 do? Now, normally you would think it goes left, but you remember if it's in parentheses, this one you always have to switch the sign on. So if it's a minus 3, I'm really going to shift to the right 3. And then the minus 2 at the back tells me to go down 2. Okay, look at the next one, 2/5 in the front. Will that be a stretch or a compression? Compression, very good. Okay, because it's less than 1. What about the plus 6? This is the opposite one. Left 6, and then the plus 1 will be up 1. Okay, look at the next one. What does the negative in the front do? Okay, it's going to reflect down, or if you put flip, that's fine. Just know they'll say reflect on the exam. And then the next number is a 3. Now, it's not a negative 3. You're just looking at the 3. So is 3 bigger than 1 or less than 1? Bigger than 1, which makes it a compression or a stretch? Stretch. Good. And then for the last one, there's a plus 8 there. That would be up 8. Okay? Do the last one for me, and then we'll go on to the next section. Okay, so the district makes your semester exam, not the Algebra 2 teachers. So they put something on there that we didn't cover, so I'm going to teach it to you really quick. If they put this number, see how usually it's in the very front? If they put it on the inside of the parentheses, then it does the opposite. Okay, so there's one like this on your exam, and we don't want y'all to get it wrong, so we're going to cover it. But like, look at number 6. See how the 1/2, instead of being in the front, it's inside the parentheses? That just changes its job. So instead of being a compression, it's actually going to be a stretch. Okay, and that's not too weird, because think about, whenever it's in the parentheses, what does it do? It does the opposite thing. So it's just the same thing for that number. Now, if there's a minus 3, which way will that translate it? To the right 3. So that's the same. But if they put it inside, it does the opposite. So now on the next one, I have a 3 on the inside. Normally that would be a stretch, but since it's inside, it's a compression. So if it's in the front, it does its normal thing, but if it's on the inside, it flips it to do the opposite. Then if I have a plus 3, a plus 6, I go to the left 6. Okay, so do 4 and 5, then we'll check them. Each of these are going to have 3 changes. Okay, for that first one, number 4, it's going to be negative reflects it down. What does the 2 do? Stretch or compression? Compression. Normally it would be a stretch, but it's on the inside. Then a minus 1 is to the right one. Next one, I have an 1/8. Normally that would be a compression, but since it's on the inside, it's really a stretch. Minus 2 is to the right 2, plus 4 is up 4. Got it? Okay, you are going to do 6 and 7 on your own at the end. So come down to the next section, please. Okay, inverses. What you should remember about inverses is that they're always backwards from each other. So what I want you to do is, on the graph, we're going to find all the pretty points. Okay, we're going to list them out, and then we're going to see which of these would be a point on the inverse. So let's start here at 3. What would that ordered pair be? 0, 3, good. Then I'm going to go to the next pretty point on the graph. Okay, so if I'm looking down to over 1, that'd be here. What is that as an ordered pair? 1, 1. Okay, next point is here. That'd be 2, negative 1. Next point here would be 3, negative 3. Next point here would be 4, negative 5. Okay, etc. Now I'm going to go up the other way and list a couple of points. So this one here would be negative 1, 5. And then the next one after that would be negative 2, 7. Okay, now remember that if these are the points for f, the points for f to the negative 1, that's the inverse. You switch the x and the y. Okay, we did this a while ago. But if these are the points for the original, then your inverse points are all backwards from each other. So it's saying which is not a point on the inverse. Okay, well, if this is negative 5, 4, then is 4, negative 5 a point? Yes, so that's going to be on the inverse. Okay, next one was 0, negative 3. Was negative 3, 0 a point? No. B is the correct answer. Now look at the other ones. If that's negative 1, 2, the reverse of that would be 2, negative 1. That's a choice. And then my last one was 5, negative 1, but negative 1, 5 is a point. So remember, all that you should be doing is switching the order. You shouldn't be changing the signs. Okay, so remember, for inverses, you're switching the x and the y. They should be backwards from each other. Okay, turn the page, please. Almost done. Okay, next one says, which is a point on the graph of? You're going to do that one on your own. Okay, 9, 10, and 11 down here. This is how to find the inverses. If you don't remember how to do this, okay, let's do y equals here because we don't like the f of x. Okay, it's 3x plus 1 plus 2. The way that you find an inverse is you switch x and y, and then you just solve for y. So if I'm doing this first one, I'm going to reverse the letters. So this is going to be x equals. This is going to be 3y plus 1 plus 2. And then I'm going to get the new y by itself. Remember, inverses, x and y are switched. That's like the big thing you have to remember for these. So if I want to get my y by itself, I'm going to do two things. The first thing I'm going to do, that is a step probably most of y'all will skip, is I'm going to switch the sides. I want to keep my y on the left side, so I'm going to make it 3y plus 1 plus 2 equals x. And I'm going to just reverse it so that my y is back on the left. Now, if this is a plus 1 and a plus 2, can I combine that? Okay, that'd be a 3y plus 3. And then I'm going to drop my railroad tracks, and I'm going to get the y by itself. So how do I get rid of a plus 3? Minus 3 here, minus 3 here. Notice I'm not going to line the minus 3 up with the x because they're not like terms. These guys cross out. I have 3y equals x minus 3. What would my last step be? Divide by 3. And then when I do that, my 3's here are going to cross out, and I would have y equals x minus 3 over 3. That would be your answer. Now, you also could divide by the 3 separately on the x and the 3. That's fine if you want to do that. It doesn't really matter. Either one. Okay, let's say we're doing number 10. First thing that you're going to do is switch the x and y. Remember that f of x counts as a y. F of x counts as a y. So when I switch the letters, instead of being y equals, now it's going to be x equals. And then instead of 5x, now it's 5y minus 7 plus 3. After I switch the letters, I'm going to switch the sides. So all of my y crap is going to come first. My x crap is going to come second. So it'll be, now can I also go ahead and distribute this in this step? Is that fine? So 5 times y would be 5y. 5 times minus 7 would be minus 35 plus 3. And then my x is going to go over there. So I take the x side and the y side, I switch the letters, then I switch the sides. And then I'm going to combine like terms before I finish solving. So what is negative 35 plus 3 here? negative 32, good. And then how do I get rid of negative 32? Add it to the other side, plus 32 and plus 32. Notice I'm not lining it up under the x because I know they have to stay separate. They're not like terms. And then from there I'd have 5y equals x plus 32. One last step, what do I do with the 5 in front of the 5y? Divide. And so then I'd have y equals x plus 32 on top, 5 on bottom. That'd be your answer. Okay. Yeah. Huh? You can do it right when we finish this. Okay, last one like that. Look at it. Remember, f of x is the same as a y. So I'm going to switch the letters. So instead of y equals, now it's x equals 1/2 y minus 4, and then minus 3. Remember, you switch the letters first, you switch the sides second. Okay? Then remember that this side is going to get to come first. This side is going to have to come second. Now, let's also go ahead and distribute the 1/2 since that has to be done in the same step. What is half times y? It'd be half y. What's half of minus 4? Minus 2. Then I have my minus 3. Do I distribute the half to the 3 as well? It's not in the parentheses, right? So no, you wouldn't. Then from there, you need to combine like terms. So if it's a minus 2 and a minus 3 more, that's really a minus 5. Okay, what do I do with the minus 5 to solve? Okay, plus 5 and plus 5. So now it's a 1/2 y equals, my minus 5 plus 5 is gone, that's an x plus 5 on the other side. And then to get rid of a 1/2, remember half is a divide by 2. How do we get rid of divide by 2? Multiply by 2, so I'm going to times by 2 here, and I'm going to times by 2 here, and I'm going to times by 2 here. Remember that when you add or subtract, you do it once on each side. When you multiply or divide, you have to do it everywhere. So half and 2 cross out, y equals, that's a 2x plus 10. Okay, the very last one, if this is f of x and this is f inverse, what should be true about each ordered pair in the table? They should be what? For the inverse. They should be backwards. So if the first point's negative 1, 9, what should the new point be? Over here. It'd be, but make it backwards, so it'd be the 9 would come first, and then the negative 1 would come second. So these would just be backwards from each other. Make sense? So what would my next point be? 6, 0, then 3, 1, then 0, 2, then negative 3, 3. Okay? So you have 4 days of review. You need to go back and finish. I think there were 3 we didn't do. Then when you're finished, you're going to come show it to me, and I'm going to check you off. You can keep it if you need to study. Okay? People that were gone yesterday, you guys need to take your test. So I'm going to go ahead and have you do that now. Make sure you don't have a phone or anything out like that. Okay? And then also, if you did not give me a review yesterday, that is for a grade. So go ahead and turn it in to me now if you have it. Okay?